Okay, so let's do a couple of more examples with the ions practice. So I'm just going to go ahead and do the first example in each of these tables just to get a little more acquainted. So what is an ion? So an ion just means it's an atom that's either lost or gained an electron. So remember, with atoms, we've got those positive protons in the nucleus, and then we've got those negatively charged electrons in the electron cloud. Now, normally, as we've learned so far, like with our 8-man, we know that typically the number of protons equals the number of electrons. So like, for example, carbon has an atomic number of 6, so he has 6 protons and typically 6 electrons. This means that the atom is neutral, because if 6 plus in the nucleus and then 6 minus charge in the electron cloud, they cancel each other out. Right? So when we talk about ions, we're just talking about atoms of elements that have either lost or gained their electrons. Okay, so they've either kicked them off or they've taken them on, and then this changes the charge of the atom. Okay, the thing that makes it tricky is that because electrons are negatively charged, if we gain the electrons, the overall charge is going to be negative because they themselves are negative. If we lose the electrons, the charge will be positive. That's the thing that always kind of is easy to get tripped up on. Okay, so let's go through these and let's go ahead and do some examples. Okay, so part A is the neutral atom. This is what we've been doing with our 8-man all along. So this is just kind of a review of that. Okay, so we're going to need a periodic table for this. I have mine over here. Let me pull it up. All right, so fluorine, we need the symbol for fluorine, so we're just going to find him on the table. He's right here. So the symbol for fluorine is F. And then our atomic number is 9. So that's our atomic number. Now, this is a neutral atom. So remember 8-man. So A is equal to P is equal to E. So the atomic number is equal to the protons, is also equal to the electrons. Okay. The atomic mass is 18.9, so I'm going to round it to 19. And then our neutrons, remember that's the man part of 8-man. So mass minus our electrons, or our protons, sorry, mass minus atomic number, which is our protons. So 19 minus 9 is 10. Okay, so that's how you do that. That's just a review of 8-man. So in here, we're assuming that the number of protons are equal to the number of electrons, and it's a neutral atom. Anytime we have a neutral atom, we just leave the symbol by itself. So it doesn't need a plus or minus because it's neutral. It has no charge on it, so we just leave it plain. Okay? All right, so now let's look at isotopes in part B. So the isotopes in part B is just, again, a review of that 8-man. So in this case, all that's changing here is the neutrons. Remember, isotopes have the same number of protons, but a different number of neutrons. And we can tell because it's got this hyphenated symbol here, right? So up here, we saw from the table that the mass was 19. We rounded it to 19. Here, it's going to be 20. So we know those neutrons are going to be changing. So same thing. We've still got fluorine. We've got an atomic number of 9. We still have 9 protons. We still have 9 electrons here because this is still a neutral atom. And then now our atomic mass, instead of 19, is going to be 20 because, again, this is an isotope, so we're changing in the number of neutrons. And so then 20 minus 9 is going to give us 11 neutrons, okay? So in part A, you're just doing the typical 8-man, right? You're going to use the periodic table to find the average atomic mass, and then you're going to do your 8-man calculations. Part B, with the isotopes, we are only changing in the number of neutrons, okay? So for like 10, 120 will be your mass here. So the mass will be 120, and then in part A, you have to find the atomic mass from the table, okay? Now here is where the ions come in part C, okay? Here, if we see our symbol, now we have these charges. The charge on a chemical symbol tells us that something has happened to the electrons, okay? So like in part B, it was the neutrons that are changing. In part C, your electrons are going to change, okay? So we already know for fluorine, our atomic number is 9. And then our atomic mass was 20 here. We're going to have 11 neutrons, just like in B. and we're going to have 9 protons because the atomic number is always equal to the number of protons, so that wouldn't change. So here what's changing are electrons, okay? So remember, in a neutral atom, we would have 9 electrons, right? So 9 would be the number of electrons we would typically have. However, this charge is letting us know that we have lost one, right? So we have lost 1 electron, or gained 1 electron, sorry. So the -1 lets us know we gained 1 electron. See, it's tricky. You got to keep it straight in your brain. So when you gain an electron, you get a negative charge because the electrons have a charge of -1. So if you see -1 as a charge on an element, it means you've gained 1 electron. If you gained 2 electrons, the charge would be -2. If you gained 3 electrons, the charge would be -3. It just depends on how many you're gaining here. So in this case, because it's a -1 charge, then that means I gained an electron. So instead of having 9 electrons, I would have 10, okay? So remember, if we gain the electrons, it's going to be a negative charge. If we lose the electrons, it's going to be a positive charge, okay? So in part A, it's just 8-man all the way through. Part B, the only thing that's changing are the neutrons and the mass is based on now the isotope. And then part C, every number will be the same as in part B, except for the electrons will change, okay? So now what that means for 10, so if we see 10 has a charge of 4 plus. That means he lost 4 electrons, okay? Because when you lose electrons, you become positive. When you gain electrons, you become negative. So like the fluorine here, he gained 1 electron because his charge was -1. So we added 1 to his electrons here. So after you calculate your electrons from 10, so you'll do that from the periodic table. So you'll find 10 on the periodic table. The atomic number will equal the electrons. So that is what you're going to modify here. So once you get the electrons from the periodic table for 10, what you're going to do in part C is, because we've lost it, you're going to take that number of electrons and you're going to subtract 4 from it, okay? Because we've lost 4 electrons. So whatever number you calculate for the electrons in part 1 for 10, down here for the ions, you're just going to subtract 4 because we've lost 4 electrons, right? Gain electrons, negative charge. Lose electrons, positive charge. And the number of the charge just tells us how many electrons we've lost or gained. So again, like fluorine, we gained 1 because its charge is -1. For 10, we lost 4 because the charge is 4 plus, okay? So try to do the 10 on your own. Again, remember this is 8-man, all that's changing is the neutrons, and then down here we're changing the electrons. So all the numbers in this one should be the same as what you find in B, except the electrons are changing, okay? And of course, if you still need help, we'll go over it some more in class.